Hello, and welcome to a video tutorial about the different base systems. In this video we will be talking about the decimal or base 10, the decimal or base 10. This will be the decimal, right? I'm just going to shorten that to dec. Hexadecimal, which is base 16. And then binary, which should be base 2. Except I will be color coding this. This will be red. I believe this will be green, and the other one will just be white. So we're going to start off talking about, I think, hexadecimal. We're going to start off with a number like, say, 50. So in decimal, we all see this as 50 normally, but if we were to convert this over into like hexadecimal or even binary, it would be a lot different. Now I'll explain how you find this like you will find the others. Now basically in base 10 it's 0 times 10 to the 0 power for the first one. For the second one it would be plus 5 times 10 to the first would basically be how you find this, which you will see this is true because this would be 5 times 10, which is 50, plus 0, which is 50. So now when we go over here to hexadecimal, this is base 16, so it has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A for 10, B for 11, C for 12, 13, 14, and 15. And basically, rather than it be like this, it would be more like, say, 0 times 16 to the 0, which would be 16 times 1, plus like 5 times 16 to the first, right? If we were using the same numbers now. To convert this over to the other one, we need to think about the tens first. So to get to 50 in terms of 16, that should be a 3, because 3 times 16 to the first is 48, and we need 2 left, so then it should be 2 times 16 to the 0, which would be 2, which gives us 50. So this would be 32 over here. And in binary, it's just 0 and 1. And the way it works is basically it's of the 2 in other instances. So in the first one would be like 0 times 2 to the 0, which would be, it could be like 1 times 2 to the second, or actually the first, but then goes to the second. So now we got to think about the nearest square, so power of 2 that will get us to 50, which should be 32, which means we'll be going, so it starts off in hex binary, 1, then 2, then 4, then 8, 16, 32. So this is be 1, 2, 3, 4, 5, 6. So we'll have 1, and then from 32 to 50 we will need 18, which means we'll have another 1 here for the 16. And that brings us 2 short, so we'll have 2 zeros, and then the 1 and the 0. And then to read this, it's basically, okay, so this right here is 0 times 2 to the 0 power. This one right here would be 1 times 2 to the first. Now basically, this basically will be then 2 to the second, 2 to the third, 2 to the fourth. So that's a 3, and it decided to do a 4 there. 2 to the fifth. And basically, if it's a 1, then it's this number plus the other numbers, and if it's a 0, then it's basically not. Basically, the binary is what computers read as true or false. 0 being false, and then 1 being true. This is kind of how programming works. don't really, yeah, computers run off of 0 and 1. That is the bases explained by me. I'll have another video going more in depth into each one with more examples at a later date. Okay, I wanted to prove that this, right, let me get a different color, that this, and this are all the same in their corresponding things, because this is decimal, this is hexadecimal, and the last one here is binary. And so basically we're going to check with a calculator that comes with it, with Windows. So we'll pop up the calculator, and in Windows 10 it kind of looks like this. So then we'll go to Programmer, which I already have. So we'll have decimal, and we'll type in 50, press enter, and we'll see the different bases. So in hexadecimal it is 32, so have 50 as the decimal, hexadecimal is 32, and then binary should be 110010. 110010. So they do match. Therefore, this proves this. And you might wonder, well, why don't we just use the calculator all the time? Well, if you don't have a calculator that can do this, A, or B, you don't have a calculator at all to do this, like maybe you're in a math competition, it would be good to know how to do these. Thanks again for watching. Be sure to subscribe for more, and like if you like